Good afternoon, students. Today, I am going to explain the comparison between the VHDL and Verilog. As in the previous lectures, we have discussed the some basics of VHDL. Now we know that there are two types of hardware description languages. One is your VHDL and second one is your Verilog. Okay. Now, what are the various differences between the VHDL and the Verilog? I will discuss it one by one. Actually, VHDL, VHDL as compared to Verilog is your difficult and complex language, whereas your Verilog is a simple language as it is similar to C language. Means Verilog is same as a C language, but VHDL has no consideration with C language, so that's why it is difficult and complex as compared to the Verilog language. Now the second major difference is VHDL is actually a strongly typed language, means which includes all the libraries, packages, subprograms, functions, and the procedures. But in case of your Verilog language, these type of features are not available. So that we can't do the code sharing and reusing of the code can't be done in the case of your Verilog. Also, the VHDL is used for the larger complex design because this language has the advanced features, whereas your Verilog is a simple language and this is mostly used for the primitive designs. In case of VHDL, library is present to store the compiled VHDL code, whereas in case of Verilog, the library is not present. VHDL simulation is slow, whereas simulation process in case of Verilog language is fast. Your VHDL language allows user-defined and pre-defined data types also. But Verilog allows only predefined data types. Your VHDL language is case insensitive, means you can write this language in the upper letters or the lower letters as well. But your Verilog is a case sensitive language, means upper letter, lower letter affected the language like C language. Then VHDL has mode operator, mode operator, which is not available in the Verilog. As compared to Verilog, it is very useful for the having the reduction operator that is not available in VHDL. So it means that VHDL has mode operator which is not available in the Verilog, and Verilog has the reduction operator which is not available in the VHDL. So these were some of the differences between VHDL and Verilog, even though both Vhdl and Verilog are most prominent HDL language used by the hardware designers in the industry and academic. Both languages have constructs with which the design can be fully described at all the levels. And both languages are the design languages. Only difference is in their data types to the complexity levels of the circuit are to be designed. So this was the concept of differences between Vhdl and Verilog. So after now I am compiling these. The data type used in Vhdl are type-oriented language, user-defined type, and can handle multi-dimensional array types. Whereas in case of Verilog, the data types used all are predefined. We can't use the user-defined type and this language can't handle the multi-dimensional array types. Now the second ease of learning. Vhdl is complex. I have already told you it's difficult due to its library and packages. It can be attached to the standard Vhdl packages, all these. But in case of Verilog, this language is easy. In this language, we have to just write the module without worrying about their library and the packages. So there is no concept of library and packages are used. And third is your operators. The Vhdl operators does not have any predefined unary operators. So VLSI, in case of that, have the predefined unary operators. The last point is procedures and tasks. The Vhdl language allows a function to be written inside the procedure body, and in case of Verilog, functions are not allowed to be written inside the task body. In your Verilog, we have procedures and tasks. So these are some of the differences between the Vhdl and Verilog. Now come on to the next topic, that is basic terminology used in Vhdl. There are mainly 5 terms which are used in Vhdl language. First one is entity, second is architecture, third is configuration, fourth one is package, fifth one is subprogram. Now I will discuss these 5 basic terminology one by one, giving the brief idea behind that. The very first basic terminology is entity. Okay, what is an entity? In the Vhdl, An entity is a circuit or sub-circuit that described with the Vhdl code is called an entity. Means it is a circuit or sub-circuit described with Vhdl code is called an entity. An entity has two main parts. First is entity declaration and second is architecture body. The entity declaration specifies the input and output signals for the entity. Means input output signals is specified in the entity declaration part. Now the second part is architecture body. The architecture body gives the circuit internal details. Means internal knowledge of the circuit is given by the architecture body. Now the second one, basic terminology used in Vhdl is architecture. An architecture actually specifies the internal view of an entity for a circuit, and all the entities to be designed in Vhdl have an architecture body. Means the entity which is written in the Vhdl also have an architecture body, and a single entity can have multiple architectures. Means single entity can be used in different multiple architectures. Now the third basic terminology of Vhdl is configuration. If an entity have multiple architectures, a configuration is used to find an entity to a particular architecture or to find an entity architecture pair. Means if we have multiple architectures, then configuration is used to find which entity is related to which particular architecture, or also finding a component to an entity architecture pair. Now the fourth one, The fourth one, basic terminology of Vhdl is package. What is the function of package? Actually, it provides a mechanism to store and share commonly used declarations that are common across many design units. And commonly used declarations are such as data types of Vhdl, subprograms used in Vhdl, then components used in Vhdl. Package is actually represented by a package declaration and its package body. Now, come on to the last basic terminology of Vhdl is subprogram. Subprogram is a sequential algorithm which performs certain computation. Actually, it's a sequential algorithm. And these algorithm uses the value of input parameters which are passed to the subprogram for computing the final results. Actually, there are two types of subprograms in Vhdl named as functions and procedures. So, these were the 5 basic terminology used in Vhdl. Every programming part will at least contain an entity and an architecture body. So, first of these two are very essential for writing the program or code using the Vhdl language. So, with this, we have completed this topic also. Now, going further with the concept of Vhdl history. Actually, we know that Vhdl is basically acronym of for V for VHSIC, that is very high speed integrated circuit, and HDL stands for hardware description language, which is used to model a digital system at many levels of abstraction. That means from designing from the algorithmic level to the gate level. Actually, a team of DoD, that is Department of Defense, developed the language, and this language is released in 1985, and in 1987 this language is Vhdl language is firstly standardized in IEEE 1076 1987 standard. Its upgraded version or enhanced version of this language was released in 1993, and in IEEE it is known as IEEE 1076 1993. Actually, today Vhdl is most widespread hardware description language, and this language is supported by the CAD tools, computer aided design tools. This language actually supports the hierarchy modeling of the system and top down and bottom up methodologies of the design. This language can be treated as an integrated merger of the some of the languages like sequential language, concurrent language, netlist language, timing specifications, and waveform generation language. Means this is the merger of all these languages. Everything is available with this language. So this language enables us to express the concurrent and sequential behavior of our digital system with or without timing. We can also interconnect the various components. We can also generate the test waveforms. So all these features are combined to provide a comprehensive description of the system. Using a single model used in the Vhtl. This complete language actually has the sufficient power to capture the descriptions of the most complex shapes to a complete electronic system. So this was the history of this language. Now moving to the further concept, that is Vhdl features. Means what are the various features of this language? As we know that Vhdl is a very powerful design tool or popular design tool in industry and academia. We can design our digital systems at different level of abstractions. From gate level to the complex digital system. So there are so many features of this language, the very first one is, this is case insensitive language. Whereas you know that here Verilog is case sensitive, but this is case insensitive language, means we can write in this language in upper letters as well as lower letters. Second feature is Vhdl is a strongly typed language in which we have to use the dedicated conversions, conversions functions. These are needed to convert objects from one type to the another. Now the third feature is the design may be decomposed hierarchically. We can decompose the design in Vhdl using hierarchy model. Now the fourth one feature is Vhdl includes advanced features such as package, subprograms, generics, and configurations. Now the next is where use of concept of generics. So next is use the concept of generics and the attributes to contribute, actually to describe the parameterized designs. Now the next feature is Vhdl supports design entry. It supports the design library actually. This language also handles asynchronous and synchronous sequential circuits also. Now the next feature is we can define new data types, means user defined data types can be defined along with the predefined data types. Now the next is Vhdl is a technology independent language. So that's why it is portable. Means a program which is written on one software can be run on the other, and the program can be portable, means it can be stored into the pen drives also. Now the last one feature is Vhdl does not depend only or stick to the user only one style of description. Rather, it depends. It supports three types of descriptions. One is data flow, second is behavioral, and third is structural. So, with this, I have completed this topic also, that is Vhdl features. Now we will do the next concept, that is your Vhdl design methodologies. There are two types of design methodology. First one is top-down design methodology, and the second one is bottom-up design methodology. Firstly, I will discuss top-down design methodology. We know that in Vhdl, basically, we use these two design methodology. In the case of top-down design methodology, it is used for optimizing the design cells which are at the top level. So you can see in the diagram, there is a top level cell, and this is from top. We will move from the top to the down. Top level cell is further divided into subcells. Then each of the subcell is further divided into the leaf cell. Means we are going from the top to the bottom side. Means from the top to the down side. So we are at the top level of design hierarchy. Firstly, we will define the top level cells first. Then we have to identify the subcells. After the placing and routing of the top level cells, same type of distribution and assigning of signals for lower level is completed. In this top-down design methodology, we can easily change the distribution according to the application, but to change assigning of signals at each stage is not an easy task. So this diagram shows the top-down design process. Now come on to the next design methodology, that is bottom-up design methodology. Now you can see we are moving from bottom to the top or bottom to the up. So at the bottom side we have the leaf cell. Then each two leaf cell will be given to the macro cell. Each macro cell. Further, these macro cells are provided to the top level cell. So this is the bottom up design methodology. In this method, we can use this method for optimizing the design cells which are at the bottom of the design hierarchy. Firstly, we will define or identify the cells which are available to us. Then we build bigger cells from them, means from these leaf cells we build bigger cells, that is macro cells. Then these macro cells are used for further higher level cells until we build the top level cell in the design. Means these macro cells are now combined or used for the higher level cells until we reach the top level cell in the design. So this is the bottom up design methodology under the concept of Vhdl design methodologies. So with this, we have completed this topic. Now further, I will discuss with you the basic elements used in Vhdl language. Now going further slide, the basic language elements. In Vhdl, the basic elements used in Vhdl language are: first is identifiers, second is data objects, third is data types, and fourth one is operators. Now I will discuss these elements one by one in detail. I will start it from the identifiers, then I will move to the data objects. In the further lectures, data types and operators will be discussed. Now going on the further slide, first one basic element used is identifiers. Okay, what is identifier? Actually, these are used to name items in a Vhdl model. These are called as identifiers. For writing the identifiers, we have to use some rules. How identifiers are formed, we have to follow some rules. Identifiers are basically classified into two types. First is basic identifier and second is extended identifiers. A basic identifier contains the alphabetic letters capital A to capital Z, then small a to small z, and the decimal digit 0 to 9, then underscore. Means a basic identifier contains the four named items. First is capital A to capital Z, then small a to small z, then 0 to 9, third is 0 to 9, and fourth is underscore. Actually, basic identifiers cannot be Vhdl keyword. It must start with an alphabetic letter and may not end with the underscore character. Also, the rule is that it may not include two successive underscore characters. So some of the basic identifiers examples for that is like b, small bl, test, test, count next underscore value. These all are the basic identifiers. But no one identifier can't be started with the numeral or starting with the underscore or ending with the underscore characters. We know that Vhdl is a case insensitive language. So small test identifier is similar to the capital test identifier. Now I will discuss this or writing the examples for the basic identifiers on the blackboard also. Now, if I will summarize the basic identifiers, as you can see on the blackboard, that the example for the basic identifiers are small b, small bl, test, it can be a basic identifier, then count then next underscore value. These all are the possible basic identifiers. Some rules you have to follow in the writing the basic identifiers. So there are also some examples I have written on the blackboard of the illegal basic identifiers. Means first illegal basic identifier is, let us suppose we have one bit under hyphen counter. Why this is illegal? The rule said that first letter should be your alphabet. First letter should be your alphabet for writing any basic identifier. Okay. Now the next is underscore b. We can't write underscore in front of any letter. Means first letter always and always should be your alphabet, not underscore or not any numeral. So this is also invalid. Third is no basic identifier should be ending with the underscore. And the last rule to write a basic identifier is that two consecutive or two successive underscores are not valid. As you can see in this example, clock, double time, underscore, pulse. So there are two successive underscore. That's why this also becomes as your illegal basic identifiers. So these are the examples for the illegal basic identifiers. Now the next point I have already discussed with you that if I am writing this basic identifier as TEST and one basic identifier is written as here TEST, so capital TEST and small TEST. Actually, we know that our Vhtl language is case insensitive. That's why these both are identical. That means these both are deal with the same. So these were the explanation for the basic identifier. Now come on to the next is here extended identifier. Next is extended identifier. Okay, I will write the examples for the extended identifier. As sometimes actually we have need to use these special characters in the identifiers. So the net list is generated. Net list is generated by the synthesis tools that start with a number or contain an operator symbol. We have to use in this case extended identifier means any sequence of the characters can be written between the two backslashes. Two backslashes. And some of the examples for that is count, count, hash, hyphen, or you can say underscore. Second is 22 NAND underscore gate or hyphen gate. And third example is AND. This sign and AND. So these are the examples for that. Means everything is written in the two backslashes. So these were the standard extended identifiers. So in this I have shown the examples for that. So that is this. Actually, this is different from this example is different from if I am writing like this, back count small in small letters hash. It will distinguish these two. So extended identifiers actually have the net list that is generated by the synthesis tools. Start with the number or contain. It starts with the number or contain an operator symbol, and to address Vhdl 93 means the Vhdl version that was come into existence in 1993 is known as Vhdl 93. Vhdl 93 has introduced the concept of actually extended identifiers. So a sequence of any characters like count, 22 NAND underscore gate or hyphen gate, any sequence of any characters can be embedded between the two backslashes. The lowercase and uppercase like count, small count and capital count. Lowercase and uppercase characters in extended identifiers are considered to be as different. So these were some of the examples of extended identifiers. Now come on to the next is your comments. Next is your comments. I will write the example for the comment, then I will discuss the comments in the, what are the comments in the VHDL. The example for that is have the following code models. This is the example. Following code models. Then is again two hyphens. The control section of the system. So in the case of VHDL, if I will put two hyphen sign, then write any text after this, this will be treated as comment in the VHDL. So similar to other programming languages, the VHDL also supports the commands and two consecutive hyphen mark. As you can see in the example, two consecutive successive hyphens mark the start of a command. In that case, compiler ignores any text on line after the two successive hyphens. A comment can be on a separate line or at the end of a line of the VHDL code, but in any case stops at the end of the line. It can appear, comments can appear in anywhere within a description. We can also write long comments on successive lines, and each line should start with two hyphens. Means we can also write the long comments, but in each line for comment we have to put the two successive hyphen marks. So this will be treated as the comments. Now the last is the reserved keywords. Last is here reserved words in the VHDL. Okay, I will also show you the table for the reserved words. Okay. In case of VHDL or some identifiers called keywords or reserved words are there. Actually, these reserved words are special use in VHDL, and these reserved words can't be used as an identifier. The various reserved words are like port, entity, is, in, out. These all are the reserved words, and these can't be used as an identifier. So these are the some of the examples. I will show also you the table which includes all the reserved words, and these reserved words should not be used by the basic identifier. And all the reserved words are in the bolded form. That is, all the reserved words are in the bolded form in the VHDL programming language. Means if I'm using port, port, then definitely in programming it will be written in the bold form. Now further I will show you the table which is used for which gives the various reserved words used in Vhdl language. Okay. Okay, students, this is the table for the reserved words used in Vhdl. These all are the reserved words which are used, and we can't use these words as an basic identifiers like ABS, assets, software, lies, all, and architecture, array, assert, attribute, then begin, block, body, buffer, bus, case, component, configuration, constant, disconnect, down to, else, if, friend, entity, exit, file, for, function, generate, group, guarded, if, impure, in, initial, in, out, is, label, library, linkage, literal. These loop, map, mode, these all are the various keywords, or you can say the words which are used in Vhdl, and all should be in the bold form while doing the programming. So not, nor, neck, XNOR, XOR, use, variable, wait, when, while, type, to, subtype, return, ROL, ROR, these signal variable, these all are under the category of your reserved words in the Vhdl. Now with this I am ending this lecture. In next lecture we will go through the data objects. We will go through the data objects of the Vhdl. Till then, we will meet in the next lecture. Till then, thank you. We will meet in the next lecture.